Hey guys, so I've discovered that the microphone on this computer sucks, so I'm going to have to talk kind of loud. Sorry if it sounds like I'm yelling at you. First thing you need to do, if you have not yet downloaded the worksheet that goes along with this, it should have been in your email. Please make sure that you download that so that you know what questions I am working through. So this is going to be question number 1. We have lead nitrate reacting with sodium iodide to produce lead iodide and sodium nitrate. I know that I have 12 grams of lead nitrate and 12 grams of sodium iodide, and we want to know how many grams of lead iodide that can make. This is called a limiting reactant problem, and we know that because we're given an amount for both reactants. One of those reactants is going to run out first. It's like when we talk about driving. We talk about running out of gas, but we never talk about running out of oxygen. We have plenty of oxygen that is in excess. In this example, we are going to figure out which one of these we're going to run out of first. So, we're actually going to do 2 stoichiometry problems, one for each amount given. The first amount that was given is 12 grams of lead nitrate. I'm going to follow my 4 steps. I'm going to take the amount given and I'm going to put it over 1. Hopefully remember your second step, which is to convert to moles. So I'm going to use my molar mass. Because we're in grams, we're going to be using our molar mass. The molar mass of lead nitrate is 331.08 grams, and that just comes from the periodic table, for every mole of lead-2 nitrate. Alright, so now that we're in moles, we're going to use our mole ratio. Since this is moles of lead-2 nitrate, we're going to put moles of lead-2 nitrate down here. So for every mole of lead-2 nitrate, we have 1 mole of lead iodide, lead-2 iodide. And the reason that I'm going to lead-2 iodide is because that's what the question asked me about. It said if we have 12 grams of lead nitrate and 12 grams of sodium iodide, how much lead iodide can we make? So my last step here is going to be to convert this to our desired units. And our desired units are grams, and again, that should be in your question. So the molar mass of lead-2 iodide is 461.00 grams for every mole of PbI2. Alright, so we're going to make sure that all of our units cancel properly. They do, very exciting. The answer to this with significant figures is 17 grams of lead-2 iodide. Okay, that's only half the battle. So what we've seen here is that if I have 12 grams of lead nitrate, I can make a maximum of 17 grams of lead iodide. Okay? So our next step is going to be to do the same thing with the other value that's given. So we have 12 grams of sodium iodide now. I've put that over 1. I'm going to convert it into moles. The molar mass of sodium iodide is 149.89 grams for every mole NaI. Right, now that we're in moles, we can use our mole ratio. Moles of sodium iodide here, so they're going to come down here. For every 2 moles NaI, we have 1 mole PbI2 from the balanced equation. Our last step is our desired units. Again, this is going to be grams. And we already know that we have 461 grams for every mole of lead-2 iodide. Okay, cancel our units. Everything went smoothly. If we put this in our calculator and use significant figures, we're going to find that we have 18 grams of lead-2 iodide. Okay, so we have 2 different reactants and 2 different answers, and we want to know who is limiting us. The smaller number, so 17 grams, always comes from your limiting reactant. This limiting reactant was the lead-2 nitrate. So I'm going to write LR for limiting reactant. In other words, by the time we get up to 17 grams of lead iodide, we have used up all of our lead nitrate. So even though the sodium iodide could make up to 18 grams, we will have already run out of our other reactant. That's what a limiting reactant does. That makes this guy, the sodium iodide, our excess reactant. In other words, we're actually going to have more of him. we will have some sodium iodide left over after this reaction. Okay, one more little note here. This answer, in this case the 17 grams, the smaller one, is called your theoretical yield. Theoretical yield. Okay? And all that means is that in theory, if everything went absolutely perfect, if we're not in the real world, this is how much we're actually going to make in this reaction. And this net value is going to become important next week. Okay? For question number 2, you're going to have to go to a different video. Thanks.